Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is STL's list collection class. Before proceeding, make sure that you have already watched these other videos first. A list is a collection class implemented by STL as a doubly linked list data structure. A list grows by allocating each linked list node individually upon insertion. That makes a list particularly efficient for inserting or removing items anywhere in the list. Even though STL's internal representation of a list is radically different than it was for a vector, its interface of functions has been designed to be as similar as possible. You can construct a new list by default construction, initialization from a literal, copy construction, or constructing a new list where all of its items have the same value. You can query how many items are currently in a list with another function that specifically tests whether or not that size is 0. You can compare two lists using equality, inequality, and lexicographical comparison operators. The first and last items can be accessed using their special names front and back, which obtains a reference. The erase function removes an iterator-specified item from the list, but doesn't do any deallocation of it. You can also remove a range of contiguous items. Remove the first or last item using pop front or pop back, or remove all items using clear. You can call the insert function to insert an item into a list. The inserted item does not need to have the exact same type as the collection, as long as it could be coerced into that type. The insert function will create a compiler temporary to hold the coerced value, and then construct the new item by using a copy constructor from that temporary. The mplace function is a faster alternative to insert. Mplace uses a one-parameter cast constructor to directly construct the new item in the collection. Instead of insert and mplace, you could use pushback and mplace back to insert the new item at the end of the collection, or use push front and mplace front to insert it at the start of the collection. You can use the assignment operator to assign a list from another list. Another assignment option gives all newly added items the same value. Both assign and resize functions will change the list's size to become the requested number of items. The assign function changes the value of all items. The resize function leaves existing items untouched, but possibly cropping some away if there had been too many. Resize only gives its new value, which can default to 0, to those items that are newly added. One disadvantage of using a list as your collection class is that it doesn't provide any random access indexing of items. So in order to access a particular item, you need to iterate to it by starting from one of the two ends of the collection. One advantage of using a list as your collection class is that the removing or inserting of a list's item does not affect the memory usage of any of the other items. So their iterators, item references, and item pointers will all still remain valid. If you want to remove all items specifying some criteria, then this remove function is more efficient than using STL's general purpose algorithm. However, you would still need to use that algorithm if you want to remove only one specific instance. The most straightforward removal criteria would be the item matching a specified value. But you could have a more detailed removal criteria if you instead specify a callable object to the remove if function. Splicing is similar to the overload of the insert function that inserted from a range of iterators. But whereas inserting copied items, splicing will move those items. Splicing is an especially efficient operation because it only requires the relinking of nodes without copying any data around. If you had omitted specifying the end of the range of iterators, then only one item would have been moved. If you had omitted both the beginning and the ending of the range, then the entire source list would have been moved. The same list could have simultaneously served as both the source and the destination. Merging takes two pre-sorted lists and produces one sorted list from them, where all of the items have been moved from one input list into the other. Duplicate items are allowed in any of those lists. If you had skipped passing the callable object to this merge function, then the standard less predicate would have been the default. This unique function removes duplicate items from the list. It assumes that the list has already been pre-sorted. These are two efficient functions for reordering list items. Again, you could have omitted passing the callable object to the sort function, letting it default to the standard less predicate.